Now we are discussing about acceleration. What is the acceleration? So, acceleration, it is denoted with A. Acceleration is a vector. So, what is the acceleration? That equals to change in the velocity by time. Acceleration equals to change in the velocity by time. Delta V by delta t. So, if it is so small, if it is very small, you take dV by dt also. dV means what? Rate of change of velocity is called acceleration. What is the definition? Rate of change of velocity. Rate of change of velocity is called acceleration. Rate of change of velocity is called acceleration. For example, one car is at rest. With the help of accelerator, I am increasing its velocity. So what happens? Velocity increasing. Acceleration means always represents velocity increasing only. If it is uniform, so what is the change of velocity? For example, I am taking one particle initial velocity u, final velocity v, time t. So from this what we are getting? Acceleration equals to change in the velocity v minus u by t. That is the acceleration. For example, one particle moving with uniform velocity. Uniform is what? In every time interval at any position from starting to ending observations, velocity constant. Velocity constant means v equals to constant. So what happens? Velocity, final velocity v, initial velocity also v only because v is constant. So finally I am getting acceleration 0. If any particle moves with a uniform velocity, v equals to constant means what is meaning? Uniform velocity. If any particle moves with uniform velocity, its acceleration is 0. So what is the definition to acceleration? Rate of change of velocity is called acceleration. Otherwise you give another definition also. For example, here I am taking time equal to 1 second. Then change in the velocity only acceleration. So what happens if one particle is traveling with in 1 second change in the velocity, that change in velocity only called acceleration. What is that? Change in velocity. Change in velocity of a particle. Change in velocity of a particle in 1 second is called acceleration. Change in velocity of a particle in 1 second is called acceleration. In the case of acceleration, there must be some force applied. F equals to ma. Again, according to Newton's second law, F equal to ma. A is there means what? F is there. Without F, A not there. Due to force only, what happening? Velocity gradually increasing. That is happening. Similarly, one car moving suddenly brakes applied. What happens? Velocity gradually decreasing. Finally goes to 0. Negative acceleration is called retardation. That is called what? Retardation. What is retardation? Negative acceleration. So if A equals to minus, that is called retardation or negative acceleration. If A equals to negative, if A equals to negative, negative means velocity gradually decreasing. Velocity gradually decreasing. Gradually decreasing, if it continues, finally it goes to rest. Final velocity becomes 0. This is also called retardation. Retardation. For example, one car brakes applied, its retardation is 2 meter per second square. When we are using retardation word, 2 meter per second square only you tell. Otherwise, car brakes applied, its acceleration equals to minus 2 meter per second square. That means what? Negative acceleration, that only called retardation. When we are using retardation word, plus 2 meter per second square del. That only another way how we are telling acceleration equals to minus 2 meter per second square. But you don't tell retardation equals to minus 2 meter per second square. Like that don't tell. So this is about retardation. So here time is scalar but velocity is a vector. So what is the direction of change in velocity, not velocity. Change in velocity, which direction? In that direction what existed? Acceleration existed. Don't tell velocity. Change in velocity direction only acceleration. So that is about acceleration. Again, classification of accelerations we are taking. Those are two types: uniform acceleration and non-uniform acceleration. Acceleration classified into two types. One is uniform acceleration and another one is non-uniform acceleration. So what is the uniform acceleration? For this you take one example. This is 0 seconds, this is 1 second, 2 seconds, 3 seconds, like this. So for example I am taking initially rest means what? 0 meter per second. In 1 second 2 meter per second came. Next year what came? 4 meter per second. Here again what came? 6 meter per second. So here what is the duration? 1 second. What is the 2 minus 0? 2 meter per second. What is the 2 minus 0? Final velocity minus initial velocity. Change in the velocity. Similarly, 2 minus 1. Here also duration 1 second. In this also. 4 minus 2? 2 meter per second. Like that. In equal time intervals, change in velocity if is same of a particle moving, its change in velocity is same in equal time intervals. Such type of motion is called uniform acceleration. In the uniform acceleration, change in velocity constant in equal durations. Similarly, you go to non-uniform velocity. What is the non-uniform velocity? You take this is rest 0 seconds. Again 1 second. Here 2 seconds. Here 3 seconds. Like this. So initially rest means 0 meter per second. Here I am taking 2 meter per second. Here I am taking 8 meter per second. Here I am taking 20 meter per second, like that. So here what is the duration? 1 minus 0, 1 second. 2 minus 0, 2 meter per second. Here 2 minus 1, here also duration 1 second. 8 minus 2, 6 meter per second, like that. In equal time intervals, change in velocity of a particle is not same. Such type of motion is called non-uniform acceleration. We are having kinematic equations. What are those? V equals to u plus ad, s equals to ut plus of ad square, v square minus u square equals to 2as. Kinematic equations having. In that, what is the A? Uniform acceleration. We are discussing all things about belongs to in our chapters uniform acceleration only. So, what are the kinematic equations? Kinematic equations. First one, V equals to U plus AD. Second one, S equals to UT plus of AT square. This is second one. Next, V square minus U square equals to 2S. Third one. Next, Sn that equals to U plus A into N minus of. Here what is the U? Initial velocity. What is the U? Initial velocity. Next V. What is the V? Final velocity. Next A. What is the A? Acceleration. What is the A? Acceleration. Next T. What is the T? Time. What is the T? Time. Next S. S is the displacement. S is the displacement. Next here Sn given. What is Sn? Traveled displacement in the nth second. What is Sn? Traveled displacement. Traveled displacement in the nth second. Nth second means last second. For example, one particle traveling from here to here, totally 10 seconds. So first second, second second, here 9 seconds. This is the 10th second. Last second is called nth second. If it is traveling n seconds, nth second. So what is the meaning of Sn? Traveled displacement in the nth second. Total time T taking. T means what? N. N seconds. Totally 10 seconds. This is what? 10th second. Totally n seconds. This is what? Nth second. Last second distance traveled displacement is called Sn. Sn means what? Traveled displacement in the ending second. That is called Sn. These all are called kinematic equations. First kinematic equation, second kinematic equation, third kinematic equation, fourth kinematic equation. Similarly, for example, velocity time curve given. For example, I am taking velocity time curve I am taking. This is x-axis, y-axis, and this is my origin. Here I am taking velocity, here I am taking time. For example, one graph is like this given. What is the meaning of this? Uniform velocity. What is the meaning of this? Uniform velocity. Here time interval. For example, in 1 second, same velocity. In 2 seconds, same velocity. Third second, same. Fourth second, same. And every second, velocity same. Velocity same means velocity constant. That is called uniform velocity. This graph belongs to uniform velocity. Similarly, for example, here I am taking velocity, here I am taking time. Here I am taking velocity, here I am taking time. For example, one graph given like this. One graph given like this. So, this is the graph. So, here you take one normal. This is A and this is B. It is making some angle theta. So, here what happened? In the first second, this is the velocity. In the second second, this is the velocity. In the third second, this is the velocity. Time increasing, velocity increasing. That is called acceleration. So it is this belongs to what? Acceleration. This represents acceleration. Now in this graph, right angle triangle, I am finding tan theta. What is the tan theta? Slope. Slope means tan theta. What is the formula for tan theta? Opposite side by adjacent side. What is the opposite side? AB by adjacent side. OB. Okay, now we take AB. B means what? Starting. Initial velocity 0. A. Final velocity. So AB represents what? This means what? Change in the velocity. This represents what? Time. So this represents what? Tan theta equal to what it is representing? Change in velocity by time. So this represents what? Acceleration. Initial velocity 0, final velocity something given. This represents what AB means. Here 0, here 20 given. What is this final thing? 20. 20 means what? 20 minus 0 only 20. So that is the change in velocity. Here what is the duration? Change in the time. 20 seconds or like that. So that is the change in the velocity by time. That is called acceleration. So slope of a velocity time curve represents acceleration. So this is about acceleration.